Today, we're going to talk about streaming data, and I'm going to build a story around it, talking about that while it might seem really new, it's actually built on a lot of old concepts as well. I'm hoping that it can be more of a discussion than me talking the whole time, so if you have any questions or comments along the way, please just let me know. Here's the objectives. We're going to try to capture a few of today's challenges. We're going to consider some of our options, and we're going to provide some resources for further investigation. Sound all right? Let's do it. We're going to start off by just running a demo. So I'm not going to go through a bunch of slides and then demo. I'm going to just do the demo right away and then show a couple of slides. So the demo is going to start setting some of the context for the further discussion. And then we could maybe revisit it later on as we learn a little bit more about some of the content that I'm presenting today. So why are we doing this? It sets the stage, and also I'm a little bit crazy because doing a live demo in front of all of you, I hope goes well, right? Here's the players. We're going to look at Kafka, we're going to look at StreamSets Data Collector, Elasticsearch, Kibana, and Cassandra. I'm assuming you're familiar with this. Is that a safe assumption? I'm also assuming that amongst you all here today, some of you are going to be really technical, some of you are really far from it, but you know words like this. I'm going to try to keep it interesting for everybody, right? Because we all have our different roles. Those are some of the technologies we're going to do. I've been building up to try to give myself a pep talk here, because I've been doing this for over 20 years, and live demos, if any of you have given a live demo before, it can go a lot of different ways. Hopefully this works. I'm going to get out of the slides. Bear with me for a moment when I switch around. Ooh. Okay, so here we've got StreamSets Data Collector, and what we'll do is we're going to eventually start and talk about this, not this pipeline, another pipeline that I have here, where we're going to take some files and we're going to stick it into Kafka. And just to make sure that I don't have any tricks up my sleeve, that this is a real demo, let's take a look at some of the things that we have here. Like, here's a Cassandra console, and if we, this is a Cassandra console. If we run a select on the table, we have no data there. And if we go back to our Kibana dashboard, we'll see that we have logs here, but there's no actual content log in the index so far. So I have this all running locally on my laptop, but this can be applied anywhere else, of course, right? So let's start out by taking a look at one of these pipelines, and this is StreamSets, and we'll talk about other options as well. But what we're going to do is from the left to the right, we're going to pull out some Apache log files, and we're eventually going to land it in Kafka. Along the way, we're going to do some things. We're going to add some fields that we want, and then we're going to look up the IP address's location, so we'll add some latitude and longitude to it. And then we're going to convert the format to Avro before we put it into Kafka. I see some heads shaking and understanding what I'm doing, so I'm glad to hear that, right? This is just one example. So what we're doing, and another way to say this on a higher level, is we're doing some transformations and some enrichments for our data. Let's just make sure that everything's okay, so we'll preview it. We'll take a look at it as the data is flowing through. So good. We can see that data is coming in from Apache and that it's being transformed along the way. We're adding some of the information I said. Then we're eventually going to land it in Kafka. So that's good. Let's fire this up. Now, some of the other players were Cassandra and Elasticsearch, and we can now see data is flowing through. Let's take a look at some of the other pipelines for that. So far, so good. I mean, I'm going to go pretty quickly here, but we'll come back to it. This is just setting the stage. So if we've got data being landed in Kafka, let's pull it into Elasticsearch. So again, left to right, we're going to consume from Kafka now and write it into Elasticsearch. And we should see data flow through pretty quickly. And if not, this will be a real demo. I'm going to go over to the Cassandra one and fire this up as well. Oh, yeah, it's a real demo. I didn't put earliest offset. Excuse me, you guys. Let me just let me go back here for a second. The other pipelines can keep running. That'll be fine. They're just going to be picking up for any new data, and what we just did is loaded all data into Kafka, and we didn't see anything new. So I'm going to reset the origin. I warned you about this being a real demo, right? So if we start putting the data back through and we go over to our other pipelines now, we should start seeing data coming through now. We'll talk about this more through the presentation of what just happened there, but what we're seeing now is an example of streaming data. We're streaming from flat text files into Kafka, and then we're landing it in a couple of different places. Let's just take it a step further. If we come into Elasticsearch, we'll see we have docs now in it. We can add it as an index pattern here for Kibana. Is anybody familiar with Kibana? Okay, cool. I'm not going to do any time options. And let's go back and import a dashboard that I created for this. Import it. We're going to associate it with the logs. And now we have a dashboard. So we should see our data in a little bit more pleasing format. Also, did it work for Cassandra? It did. So it wasn't exactly a straight line, a little bit of curves along the way, but we got through it. I'm going to go back to the slides and talk about what we just saw. So believe it or not, and hopefully it was about 5 minutes or less of the demo, we just saw streaming from log files to Kafka, and then using Data Collector, we landed it in a couple of different spots. But why would we want to do that? What's the big whoop, right? What's the big deal? Let's talk about why that demo matters. How did we get here? Why do I propose that that's a good solution? We've got other options. So let's talk about that. Let's maybe take a look at the history. And please speak up if you've got any of these experiences that you maybe have gone through yourself. So maybe in the beginning, maybe we should cue some music when we say it that way, right? Yeah. In the beginning, maybe we had applications that looked really simple. The colored boxes represented what they were good at. So we had a web or a REST API application that's stored to a database. And we started walking. And we started to add some things to our architecture that were specialized in nature. They did one thing very well, like maybe our database wasn't very good at full text search, so we added something like Elasticsearch or Solr. Maybe our reads weren't as fast as we wanted, so we added a cache. The idea, the non-technical idea, is that we are evolving our software architecture. We're now adding components to it for very specialized roles. Maybe we did some background processing through queues and workers. And then, as Tom Petty said, we're running down a dream. We start to have more and more added to this architecture, specialized again. Maybe we're writing to a CRM. Maybe we add analytics. Maybe we've added the ability to notify. Does this start to look familiar to some of you in some of the roles that you have? I'm not saying it's a bad thing. I'm just saying one of the things we probably all have in common is that we're dealing with something like this. And then if for those of you that work at larger corporations, this is amplified and multiplied, right? You have different lines of businesses that it all looks like this. Or looks like one of my kids would draw, right? But this is where we are. There's challenges with this. And I won't read the whole slide, but I can tell you from my experiences what some of the challenges are is that some of the arrows there, like that green box web API, we're writing to multiple spots. And while that looks good or it looks like a kindergartner drew it, what happens in reality is sometimes those arrows break. Sometimes I successfully write to the CRM, but I don't write to search. So now my data's out of whack. It's inconsistent. That's a problem. Also, there's all kinds of other challenges with this too. If I want to add a column to a database, and there's things either upstream or downstream that rely on a certain structure of that data, more often than not, it's not even a technical problem anymore. It becomes more of a communication problem. There's a lot of ceremony. Now this line of business has to talk with another line of business. This group has to talk to another. You have a lot of meetings. I'm not saying meetings are bad. Yeah, meetings can be bad sometimes if you don't have to have them. It can be a waste of time. There's a lot of ceremony now. Some of these arrows that we saw on the previous slide might have different timing needs. Analytics, maybe yesterday was fine to do a report every night, but now you're starting to get asked by the business to do, I need something more up to date, more 5 minutes, every minute. So timing between some of these systems are different too. And then recovery from failures. You know, I mentioned a challenge about what happens if a write succeeds to one spot but not another. How do you recover from that? It's not just a flick a switch. It makes our jobs in the trenches more difficult. Any other challenges that you all might run into? I think I want to work where you work. Yeah, so Kimberly, I should repeat the question, right? So if I heard the question correctly, it's, I've got data landed in Elasticsearch, but now I want to move it to a location that can be used from a BI tool like Power BI. Yeah, I think the question is indicative of where we're at, we're needing to move data around, right? So we're going to cover that in more detail too, that very statement of whether or not having, let's wait for a couple slides. You mind? Yeah, that's fine. All right. So thank you for jumping in. Now we're having a discussion. Please, anybody else, please jump in. Yeah. Totally. I don't know if any. It is. It's a lot harder now, and I'm sort of smiling out of the corner of my mouth. I don't know if you're familiar with O'Reilly books, but recently there was some cartoon spins on O'Reilly books, and one of the new books was the person that wrote this no longer works here anymore, like a book for that. And there's a bunch of other ones too. I've got to find it and show it up here. But yeah, that becomes a concern. Again, this is another really good comment, and it flows well into some of the rest of the slides. So let's keep going. Thank you for jumping in. So what if we could blow it all up? What if we could change it? It's one thing to complain. It's one thing to say that things are wrong, but what are we going to do about it, right? Let's talk about it. I don't have all the answers, but maybe as a team we can come up with a few. When you look at this diagram, I think there's two things that you could immediately hone in on as an area to improve. And I think they dovetail well with some of the comments here. We could look at this and say, the problem is, and the thing we therefore need to improve is that we have too many boxes. Or we could look at the arrows. Has anybody seen some of these PDFs that go around lately? Like, this is the 2018 Big Data Landscape. And each one of these icons here represent an area that might be known by some and not known by others. This, to me, represents the boxes in the diagrams. And I'm going to propose here today that that's not actually the problem. Having all of these options is challenging, without a doubt. I hate going to a restaurant and having 40 things to choose from. I don't like it, but I don't think that's a very good problem to have if I have to choose something off of that menu. To me, that's what I'm looking at. It makes our jobs more difficult, but we're talking about improving something. I don't think we start there. I think this is a real challenge, is the interoperability between things, the integration. And that's what I'd like to talk about now, is that, and our focus on solving that in order to improve all of our lives. So how do we do it? I'm sure we've all heard the saying, not invented here, where everybody's got to be an inventor. And everybody's got to come up with the grand latest idea. Hey, I mean, I've got an ego too. I like coming up with ideas, but sometimes good ideas can be found in the past. So I'm going to propose that we could look at the past for inspiration on trying to solve this particular situation that we might all be in. I think we're all in it. We just, to varying degrees. Could we use the Unix philosophy? Is there anything that we could use from 40 years of operating systems that we could apply to distributed computing? Is there anything? I think there is. I appreciate the people, especially with gray hair in the audience, that are sort of smiling at this, because like me, maybe it's not realized how that we're standing on the shoulders of giants when we talk about the Unix and the various flavors. I think there's two key concepts in Unix. Do one thing really well, stay focused, and then provide a mechanism for those one things to interoperate with each other. So you'll see a symbol up here, the pipe and redirect. I'm going to use my fancy pointer here. Piping and redirect. And then here's an actual implementation of these two concepts. So we have various commands that are doing things really well, like awk and sort and unique. And what we have between each one of them is a pipe and a redirect. I'm going to say that pipe is almost like it's streaming from one thing to the next. So if these are the two key concepts, you're with me so far? I'm not going too far, right? If these are the two key concepts, doing one thing well and providing a standardization for hooks, for inputs and outputs, pipes and redirects, could we apply that to distributed systems? Well, as I alluded to before, I think the idea of the various boxes or the icons on that landscape is fine. That does one thing well. That's specialized tools. But then, back to the challenge at hand, is how do we implement the piping and redirects? One way we could do that is a streaming architecture. What is a streaming architecture? I think it's one of those things that if you ask 10 different people, you'll probably get 8 different answers. I like to simplify as much as possible. I think a streaming architecture just involves a couple of things. It involves a log, and it involves a way to pipe in and out. So our architecture now becomes something like this. if some of you are looking at that log and thinking things like log4j or syslog or varlog messages or logminer in Oracle, I mean, you're kind of right. That's, if you're thinking of it, kind of right in the sense that we're on the same page. If you're thinking of it as a log has some fundamental concepts, I propose. And I'm open to being challenged on this. A log is time ordered. It matters the order that you're writing in that log, and it's only append. You don't ever update it. Those two things, it's that simple. And with a log, we can attach various writers and readers to it. And each one of these writers and readers can maintain where they are in reading of the log. We'll get into this in a little bit more detail, but for now, I'll stop. Any comments or questions on where I'm at so far? Am I way off the handle here? So far, so good? Cool. So how do we apply it? We need a way to, I think I already actually covered a lot of these things in the slide. These are some of the benefits, and we'll talk about it more along the way, of having a streaming architecture. So not only how do we do it, but why we're doing it, these two things. Now let's start talking a little bit more about the what's and actually in particulars of how. So in my version of a streaming architecture, we need a couple of things. We need a log implementation, and we need a way to pipe to and from the log. We also need a mechanism to redirect. So let's talk about some of our options. Kafka, Kinesis, Apache Pulsar, which was just graduated to top-level project at Apache. And there might even be more. Any more than this that I'm maybe missing? Event Hub maybe in Azure. Pardon me? Yeah, so the question was maybe RabbitMQ, and I'm glad you brought that up. Yeah, ActiveMQ. Yeah, I don't, so the comment was, is there some things there? Yeah, I think that's true, but I don't think they get us what we need in the sense that it's not time ordered. It's the right tool for the job if it's okay to be stateless, but with distributed logs like this, time matters, so order matters. So I don't want to, I don't totally disagree, and I don't want to split hairs, but because a fundamental concept of a streaming architecture has the premise, if you will, that time matters, I wouldn't call it applicable necessarily here. It still has a place in our architecture, but not necessarily here.
Is it truly time order, or is it actual numerical order? So when you have distributed systems that we can run into this, what's your precision in time?
Yeah.
Time difference, there's time differences between clocks in the machine.
Yeah, fair point.
Is it order, or is it actual timestamps?
Yeah, I think that's a fair point. I would play it back and say order is being dictated by something, whether it's time or, in the case of Kafka in particular, it's something called Zookeeper. So there needs to be a leader. Yeah. Thank you. Thank you for... Anything else? I think I got a fancy water bottle here from my hotel. I don't drink fancy water, so don't hold it against me. So the comment question was the persistency in the log, right? So does that and that, hey, if I'm writing to a log, I'm guessing here, but I'm going to fill in some of the blank. Like, hey, maybe that log I need to go back and review it 2 years later, and certain implementations of distributed logs, that won't be available. It will disappear. Yeah, it's definitely a concern, right? It's not a good spot for persistent long-term storage. If that's the proposal, I agree. Oklahoma City, I like it. You guys are participating. This is fun for me too. Thank you. So what about the pipes and the redirects? We've got some options now for distributed log. What do we do here? You can probably tell by my accent already. I come from the north, where Bob Dylan comes from, and as he once said, the times are a-changin'. We have a lot of options for piping and redirects. We have probably the well-known, the heavyweights, Informatica and Talend. There's others, right? The traditional ETL tools. Apache NiFi, which, if I followed my history correctly, was a presentation in Oklahoma in Big Data OKC in spring of this year. Pretty big news yesterday that came out. I don't know if that's going to be Hortonworks Dataflow anymore, or Cloudera Dataflow, or CloudWorks or something. I'm sure you all heard about Cloudera and Hortonworks merging yesterday afternoon. So I don't know if it's actually going to be called Hortonworks Dataflow anymore. You can write your own. You can roll your own with Python or whatever language you choose. You can use some of the specialized tools like Scoop and Flume out of the Hadoop ecosystem. Kafka Connect. You can build code on top of frameworks. I list a few up here. I'm sure all of us have heard and seen of Spark. And others. So we've got a lot of options here. And I'm going to it's the right tool for the job. So your mileage might vary. I'm going to talk about StreamSets Data Collector as one of them today. But I think some of these can be applied to others. StreamSets Data Collector just happens to be my favorite. And what is StreamSets Data Collector? I think it can be best described with a statement from Leroy Horde, who was a running back. And what he said was, Coach, if you need 1 yard, I'll get you 3 yards. And if you need 5 yards, I'll get you 3 yards. So I realized last night coming here, I probably should have had a quote from Billy Sims or Adrian Peterson or somebody else from OU, right? But I went with Leroy Horde. And Leroy Horde's point was, he does one thing well. He gets 3 yards. And that's what Data Collector does. It's good at data ingest. It's good at the integration for modern architectures.
Earlier you showed a diagram that clearly depicted the ELK stack. You had Kafka and Logcache and Cassandra. Just curious, are you leveraging Logcache in your device connector?
Yeah, I think we use it as a place that we can pipe to or redirect to. And we're pretty agnostic on whether or not it's to Elasticsearch and then used by Kibana, or whether or not Logstash would pick it up. I'd be happy to, I'm not here to sell anything, even though that I work at StreamSets, but we do have a lot of, So thank you again. Any comments on running backs? So, as I said, I'm not here to sell you anything. It's not just because I work here. I've been in software for 20 years, so there's a couple things about StreamSets that I like. It's open source. I think in modern software, you have to be. Seeing is believing, or if you ask me, actions speak louder than words. I spent a couple years doing Spark consulting. I was fortunate enough, or unfortunate enough, to travel the world doing some Spark consulting. And as part of those consultations, I saw a couple things. I love Spark. I think it's powerful and it's the right tool for the job. I think there's some challenges around it when it comes to operating it. And StreamSets fit pretty nicely with that. I also think the right tool for the job we have to be careful of, because I know I've been guilty of it, but using the shiny object in the room to apply to a problem that's not really needed by it. So I saw a lot of Spark being applied to situations where it just made it more complicated rather than an asset to it. I'm not here to bash on anything. I'm just trying to tell you it as from one person's perspective. And then I saw it beat NiFi a couple times without any drama. So for me to see that in the field, when StreamSets came and said, hey, you should consider working for us, I listened, and somehow they were silly enough to hire me. Why Kafka? Well, why not, right? We've got 3 options as of today. Let's choose one of them. If you're in AWS, I think the conversation becomes a little bit more interesting. But let's just use Kafka. Let's go ahead with that because we can apply it to the other ones. So some of the key concepts of Kafka or a distributed log, and the terminology is just going to be slightly different for some of the other distributed logs. Things like state. So we touched upon this before. Kafka is considered stateful, ordering matters. And some of the previous implementations of this, like this gentleman here and I were talking about, it was stateless. We have a concept of producing and consuming. So the ability to pipe to and from a distributed log, topics and partitions, and consumer groups. Maybe this is better explained with a diagram, if we move left to right, where the blue boxes are producing to a particular topic. That topic might be segmented into something called partitions or shards in Kinesis for performance reasons, for reliability reasons. You'll see the little envelopes there as we're passing messages. It could be different formats. In our demo, we used Avro. You can use JSON. You can use other formats. It's just abstracted in the form of an envelope. And then finally on the right, we've got consumers, and the consumers might be pulling from one or more partitions. So Kafka is actually pretty easy. The distributed log is pretty easy. Or, to me, a diagram like that looks like much more easy. Okay, so we've got demo. We've talked about the landscape. We've got some tools at our disposal. Should we go through actually applying these? Here's our challenge. Let's get data from a REST weather service, because a business user wants to include weather data in a dashboard, see if that affects sales or something like that. Fair enough? No big deal, right? In StreamSets, it would look like this as our first version. We would call a REST API, and maybe we landed in Elasticsearch, and we're done. Maybe our boss is happy. But nothing ever is as easy as it sounds in software, right? Maybe we need to do some transformations. Maybe that REST API is actually pulling in, I don't know, Celsius, and we need it in Fahrenheit. Maybe there's some fields in that weather data that are coming back as strings, and we want to put it to an integer. So we're going to do some type conversions. Does this sound familiar to some of us in the audience about some of the work we have to do for data pipelines, right? And we have options on how to do this. Maybe there's hierarchical response in the JSON, and we want to flatten it. Generally, the idea is it's not as simple as we first thought. So we've started to add some enrichment and transformations, if that sounds familiar. And then we got a change request. And somebody probably categorizes it like, this should be pretty easy, right? We want to store it in Mongo now. Or we want to land it in S3, maybe for some long-term storage. Can you do that? And we say, yeah, we can do that. We can do that really quickly. It's no big deal. We don't have to land it just in Elasticsearch. We can land it in Mongo. And maybe we just add our pipeline to this. We just add another destination. We now have 2 redirects, and we've got Elasticsearch and Mongo as a destination. But man, it seems like we're getting closer to where we started. Now we've got a pipeline that's writing to 2 spots. And now we're open to all sorts of problems, like what happens if the write to Elasticsearch succeeds and the same data to Mongo doesn't? What happens about our Mongo person or somebody reporting off our Mongo? I don't know. It doesn't matter as much as we get a new change request and we have to have a new type conversion or add something specifically for Mongo. Now we can do that in the pipeline, and we're getting deeper and deeper to where we started. So having these tools at our disposal, Kafka and the ability to build pipelines, they're just tools. We can still screw ourselves just like we screwed ourselves before. So can the streaming architecture help? Yeah, let's implement Kafka. We're streaming now. We're writing from a source and we're producing to Kafka, and now we're consuming it. And we've got 2 pipelines. Can everybody see that? We've just added Kafka into it. But technically, maybe to some people, we've got a streaming architecture. We could put Kafka on our resume now. That's resume-driven development. So that's no good. We want to do some separation, right? We say, okay, that isn't good. We've seen this movie before. Let's change that. So let's change it to 3 pipelines. Now we've got a pipeline specific for each destination. And we're getting closer. But in my world, when we're repeating logic, like we're doing here on pipelines 2 and 3, that smells. If I say screwing myself, that's too harsh? I mean, I'm a really plain speaker. I'm not very polished, right? But so I mean no offense by some of my choice of words here. We're not doing ourselves any favors when we do this. We're getting closer. What happens if we introduce a stream processor? Kafka to Kafka. Distributed log to distributed log. Let's say we consume from Kafka, we perform our logic, and we write it back to Kafka. Or maybe a raw events to refine stream processor. So we've got an example of a stream processor. And now version 4 of our streaming architecture looks like this, with our streaming processor highlighted in green. Why? Why would we do that to ourselves? Well, hopefully I've set the stage on there's a lot of benefits to this. Easier maintenance. It's easier to recover from failure. If I fail my write to a search, and I've got a pipeline that's reading from Kafka, that's maintaining the location from where it last read or the offset, if I start that search pipeline back up, or the pipeline that's pulling from Kafka to Elasticsearch, for example, I'm going to be able to recover much easier. Actually, failures don't even scare me that much anymore. Yeah, I'm a little bit behind on some of my destinations, but it is not the amount of work that I was used to before. A lot of other benefits, too. Any others? Why wouldn't I put, so the question was, why wouldn't I put the search on the other end of MongoDB? And could you tell me a little, I don't know, tell me a little bit more on why you would do that. And I don't mean argumentative, I just feel like I'm missing something. Yeah, I mean, I'd like to talk to you about that in a little bit more detail, because I may not be imagining it right when I imagine it like the following. Like, I have a pipeline that writes to Mongo, and that succeeds, and then I pick it up from there, and I write it to Elasticsearch, and that doesn't succeed. So I think it's just it's a nuance to the same problem. Now, what I like about your example, though, is that, and I'll show this later on, is that another type of pipeline, or another type of streaming architecture, is based on change data capture, where, like Mongo, you can use the op log, and you can actually stream from Mongo all changes. So I think it warrants a little bit more discussion, but my initial reaction to the proposal is that I think we're still susceptible to the dual write things, where one succeeds and another one fails. Am I scaring them away, do you think? I'm trying.
In your diagram, where do you put something like a template or I mean, things can naturally fail for good reasons. People can have estimates.
Yeah.
Why are you also that? If there's some piece of information that is invaluable, that you put on the side of that info.
Okay, so to repeat to replay it in a slightly different way to make sure that I understand it was, so what happens if bad data is flowing through?
Yeah, let's say in your service they change something and now it breaks.
Yeah,
But they correct it later on.
yeah.
Have some bad data from the source.
So I love that question, and here's why. So my company and StreamSets Data Collector, we build that right into our streaming solution that you can monitor for changes in the data. And we call that data drift, and it can mean things like schematic changes. The most obvious one, which I'm sure many of us have experienced in our careers, is that somebody adds or removes a column to a database and somewhere downstream or upstream breaks from that. Or what's even worse is that they don't break and there's the assumption that everything's working fine. So that's schematic drift. And then we have other ones called semantic drift, where maybe we've seen time coming through in a UTC format, and now it's coming through in central time and the ramifications of that, time zone being applied could have huge dollar ramifications, or IP addresses, IP version 4 addresses were coming through, and now IP version 6 were coming through. So some tools have built that in, that you're going to analyze the data and it can address that. Some are better than others.
Well, the context that I come in is you're not talking too much in this talk about the services themselves, but we live in a continuous deployment type of world, right? So like that API may not be as sustainable. You're kind of focusing everything that came after.
Yeah.
On that, but if you're deploying lots of services, there is some decent probability that a service was momentarily producing that data.
Yeah, I think there's a pattern for it. Yeah, absolutely. Yeah, so totally agree. So if the comment and the concern is, hey, we got to be prepared for circuit breaker pattern. Things break. If the previous comment was, what happens if the data changes? Now, what happens if one of the origins or destinations changes? What's going to happen then? Absolutely. What I like about what you're saying is that we've got to have built into our design the idea that things are going to fail, right? Yeah, and we've got to have architectures that are going to be resilient to that. So I completely concur, and probably could spend days talking about this. So I'm glad you picked that up and you noticed that. I would dovetail on that a little bit further and say things like, not only are we have to deal with what you so eloquently put, but as we're streaming data to these other systems, now privacy of that data becomes a huge thing, right? We're all dealing with HIPAA, and our friends overseas are dealing with GDPR, and the ability to provide that data to analytics needs, but at the same time protecting. And what we do today, I think more often than not, is we land the data and then we protect the data. Maybe we encrypt it at rest. But that opens up complications to the stream as well, that, hey, are we susceptible to data being read on the streams? So there's solutions for that too. What I really love about this is we're getting into it a little bit more. And then, do you mind if we go back to the original demo? The original demo, now that what we know now, I'd love to hear your thoughts on how it could be improved. Because it wasn't exactly ideal when we first looked at it. It was 3 pipelines. Should we go back to it? Or is the answer already obvious that we don't need to do it? Let's what the heck? Let's go back. We had 3 pipelines. Technically, we've got a streaming architecture here because we've got Kafka on our resume. We're writing from flat files to Kafka. Then we've hung a couple of other pipelines off of it, one writing to Elasticsearch, and another one going to Cassandra. They look really familiar. What's going on in these boxes here? Well, we're just checking to make sure that we've got latitude, and if we do, then we're going to write it to the destination, and if we don't, we're not. Do any of you guys play golf? I'm putting this on a tee for you guys, right? So that's one to Cassandra, Kafka to Cassandra. What does it look like for Kafka to Elasticsearch? Yeah, am I saying we should move it upstream? I think it's technically right, but I can't just let you say that. Tell me more. Go a little bit deeper than that. And thank you, by the way. Yeah, that's what I would do. That's one of the things I would do. Is duplication of logic is... Sure. So I think what you said, maybe not exactly, was we should remove the duplication of logic. So we could put that upstream, right? And that was so we could put that here. Excuse me. So we could put that logic here, that we wouldn't even write it to Kafka if it didn't have a latitude value, right? Yeah, cool. It's improvement. I think there's probably another one too.
Make it into a stream processor, just write it back to Kafka. If it does that, that's you.
I would give you a T-shirt for that answer because I think it's right on, but everybody gets one. So go grab one if you'd like. Yeah, that's the other thing I would do, right? Because what that would allow us to do is we'd have that raw stream, and then we'd have a refined stream. And maybe somebody's interested in actually consuming from that raw stream that says, I want to know how many of my data points don't actually have an associated latitude. I mean, I'm obviously making up an example, but hopefully my point is clear that, with the changing of requirements, we could do that. Introducing a stream processor would help us. So thank you. Yeah. I got to come back more often, Mark. This is a great group. It's all right. Not too bad. So yeah, perfect. I think we got about 5 more minutes left. We can open it up. I just got a few more slides. Great. Thank you for listening. That was awesome. I mean, there's more. We just went through this is top-level introduction to it, right? I know some of you know more than this, and others this might be brand new. Hopefully it helped talk about how we got here and some of the things we can apply. You're not seeing my screen, sorry. There's other patterns too. Like there's CDC examples. I see this a lot in the field where I've got an operational data store like Oracle most often. SQL Server, another big one, DB2, and now I want to start to, from a business perspective, implement more readily available reports from my operational data store. I cannot do that nightly ETL batch anymore, and my ETL job from Informatica that's running every 4 hours isn't doing it either. So we see a lot of use cases of pulling off of CDC. From a StreamSets perspective, it looks like this, where you're actually reading from a log, and then you can write it to Kafka. MySQL is another one, too. So there's all kinds of other design patterns when it comes to stream processing. We just covered one today. As I say, hopefully some of these examples were interesting. But I'm open to ideas on other ones too. Do you have some other ones that you might want to talk about? I'll give you some time to think about it and we can. Do you have one, sir?
Oh, I was walking an issue.
You were.
I was looking at IP fix. I deal with a lot of capital data and seeing it being consumed across multiple organizations. So I was excited to add it to look at this.
Yeah, cool. I'm not here to sell anything. Take a look at StreamSets Data Collector Edge for consuming network data. Tongue in cheek, right? But it's true. Look at Data Collector Edge.
So I'm a beginner at this, but
Some days I am too.
it's pretty weird. What would you do if you sort of had to manage sort of some kind of checkpoint where all your data had to wait until some escape? You're all aligned. Is there all that set up?
So I could interpret that a couple. So the question was, the question was, how do I checkpoint? So I'm gonna play it back, but I'm gonna play it back in the way that I heard it, right? Because there's a couple different ways that you could hear that. So how could you checkpoint the status of certain pipelines in order to create some dependencies or workflows between them, right? So I'm gonna call that, you must have some experience in some more traditional ETL tools, right? Yeah, questions like that always do that, and that's fine. That one could be answered a few different ways. We don't actually build in workflow into our particular product, and some, I think, the more modern tools don't do that either. You can definitely write your own through REST APIs and do your own coordination, or think about the problem in another way, and that maybe instead of that, sometimes, now I know that batch ETL is not going away tomorrow. And it's not going away next week. In fact, StreamSets Data Collector can do batch pipelines. I'm not saying that we don't have the realities of today that we're going to have to deal with. Batch pipelines are going to be here for a while. But I think the thinking on implementing new types of batch pipelines that have associated workflow is going to change. When we're streaming more often than not, the idea of having to have dependencies between them, so the landscape changes. And when we start changing from ETL to ELT, that also changes, right? And I think we're already on our way to more of an ELT. There's another part of your question too that I was thinking about, and that is, when you say the term offset, I just want to be clear about some of the vernacular that we're using here, and that also comes up quite a bit in Kafka, where the term is used for defining where you are in reading from that log. That's your offset, and that's another sort of definition, if you will, of the word offset. So I just wanted to clarify that as well. But I think I understood you the first part, right? The workflow side of it.
So you talked about the concept of doing one thing and doing it really well, and I want to get your thoughts.
I'm sorry to interrupt. That's another reason why, because we do one thing well, data ingest, and we don't do workflow. Sorry. Now I'm starting to sound cheesy. Now I actually am trying to sell something.
The evolution in terms of testing. So, when you, as a developer, now we can trust these little boxes to do one thing really well. But as a developer, we have people who are creating these things. You have to have a way of guaranteeing that this works. And it requires some thought of some sort of evolution into that.
Man, I get it, and I love the questions you're asking because it just ties in well.
Test this as a developer. If I'm writing code, I can write unit tests, I can do integration tests. But this is kind of out there. How do you make sure that you make that change, that's something about
Totally get it. Let me answer it. Yep, let me get it. But I'll just respond to it and then make sure that I understood it, right? So I think what you were saying, and if I could broaden it a little bit, was, hey, in today's architectures, there's also being a new type of process that's being applied to things like deployment and testing. And we start to say things like DevOps. And we start saying things like CI/CD. And some of us will argue about whether or not CD means continuous delivery or continuous deployment. And we're all about, it's all about the Phoenix project, right? We're all trying to turn it into a factory line yet, right? So for the non-technical people in the audience, read the Phoenix project. That's what we're trying to do in software. That's entrenched in software development, but it's maybe not entrenched in our world yet. So the question was, question/comment, should it be? Yes, it should. And how do we do it? And the reason why I was smiling and saying that I love the questions from you should grab a t-shirt back there, brother. Good. Is that I and my company fully agree. So if you ever, I'm going to point you to some resources at the end of this, but if you go to our website, we just released something called the StreamSets test framework that allows you to create pipelines through code, run tests against them, and then either pass or fail. We've got another product called Control Hub, which allows you to promote pipelines that have been passed tests. So applying some of these process things, and frankly more. We've got more that's on the way, like being able to click an arrow. You saw in Data Collector, click an arrow and say generate test for it. So seeing is believing. Actions louder than words. Check out our website because we fully agree. That's a good segue. And I want to be conscientious of the time right here. Kimberly, we've got a little, good? So if I've enticed you enough to build your own, check out StreamSets.com. It's open source. You have a variety of different options to download here. I'm going to use my fancy pointer again. Each one of these boxes here represents a different option for you to download. So you can download a Docker image or an RPM, a core tarball, Cloudera parcel, or the source itself. I'm going to point you, if you're just getting started, to the full tarball versus the core tarball, because the core versus the full, they're both totally open source, totally free. Full has more origins and destinations, like Elasticsearch and Mongo and Oracle and everything you'd expect.
So I heard you say Docker, and I just found out about Kubernetes.
Yeah.
It's really interesting, I guess. And so are you thinking about something for the future for integrating?
Yeah, the world's going that way. I mean, if you ask me, right? Goodbye Yarn. Yeah, we already have it. Yeah. I mean, we can get better at it. So what we can do today, this is not open source, but we do have orchestration via Kubernetes across data collectors. Data collectors is open source. That's what we are showing you today. So we've got about 5 different products. We can orchestrate via Kubernetes various Docker containers that have data collectors installed. And we can do that today, and we're pretty good at it. The part that we're not so good at yet, that we're on our way to doing, is elastically scaling with Kubernetes, firing up more containers when needed, drawing them down when not. We still have to go in and click like 2 buttons to say, like, I've got 3 containers running right now. It literally hit a couple of plus boxes, and it'll fire up to 5. It's still a little bit too manual for my taste yet, but we release early and often, and we're on our way. That was a simple question, and I just turned it into a super long answer. Sorry about that. So some other facts, maybe? When I first saw StreamSets, I thought, no way am I going to be interested in this, because I like writing code. And this looks like a code generator. Is it a code generator? No, it's not a code generator. It's a design tool, and you can run it in an execution engine. And I'm a little bit tongue-in-cheek here with some of these. I don't know if I'm probably too old to use emojis like this, but I'm giving it a shot. I'm trying to evolve. It's 2000 something or other. Can it scale? So that's a nice segue. We can scale via Kubernetes, horizontally scale. We can also scale other ways though too. Like some of the pipelines that we saw, we can deploy them as Spark streaming jobs. We can deploy them as Yarn-based jobs. And we can also orchestrate through our Control Hub product. So yeah, you've got some options there. Those were a couple of facts that I had first when I saw StreamSets. I'd be really curious to hear if you have some of your reactions to what you've seen so far too, if you've got some questions.
Trying to learn this. I guess, what kind of scheduling challenges there in the streams? How do you manage that?
Yeah, we have a scheduler in Control Hub, so we can schedule the different pipelines to run at different times, especially if they're batch. Like if you want to evolve to more streaming, but you have to still accommodate the batch, you can still schedule pipelines and they'll finish when they're done. So despite our name, we're still able to do batching scheduling. Hopefully you can tell by now I show you all my cards. I'm not actually crazy about us having a scheduler. We got asked about it so many times that we had to build it, but now we're starting to do a lot of things, and I like doing one thing well. Time? Hey, I couldn't have done this. I lean so heavily on a guy by the name of Martin Kleppmann. If any of this topic interests you, he's got a couple of publications out there. He was with, he's outside of Wayne Gretzky, who will always be a hero of mine. This guy's a more recent hero. Check out our website, StreamSets.com. Jay Krebs, one of the founders of Confluent and original authors of Kafka, has got some great material out there. So look at some of his stuff. Questioning the Lambda architecture is awesome. A lot of good stuff out there. And if any of this you want me to follow up with later, I'll be happy to send it to you. Or just reach out to me. That's how to get a hold of me. And I'll be happy to follow up with anything. Hey, guys, thank you. It was a pleasure being here today. And if there's anything we want to talk about afterwards, I'll be happy to.